Hello, Course 3 students, and welcome to our fourth lesson here in Chapter 4, which is all about scientific notation. So I've kind of alluded to getting into scientific notation, and scientific notation is used when we have large numbers or really small numbers that are hard to express. And sometimes even if you plugged in, really large things into a calculator, or continue to divide, you're going to also, the calculator is going to read in scientific notation. So we're going to talk about how do we go from something that's not in scientific notation to scientific notation, and then something like having a scientific notation and going back to written in what is called standard form. So our objective is I can learn to express large and small numbers in scientific notation and to compare two numbers written in scientific notation. So it's kind of like faint here, but I'm going to try my best to go through this. So it says an ordinary quarter contains, I don't even know how to say how large this number is. This many atoms. The average size of an atom is about this many centimeters across. So those are both really large numbers or really small numbers. So I'm sorry, the first one's really large, the other one's really small. So the length of these numbers in standard notation makes them awkward to work with. Awkward to work with as well as awkward to say. Scientific notation is a shorthand way of writing such numbers. So a shorter version, a little more simpler version to write it out. Numbers written in scientific notation are written with two factors. One factor is a number greater than or equal to 1 and less than 10. So that first number that you always are going to see in scientific notation needs to be between 1 and 10. So I can have 9.77, that's fine. I don't want actually 10, and I can have 1 though. The other factor is a power of 10. So I'm always going to see some number between 1 and 10 here, and then I'm always going to see it being multiplied by 10 to some sort of power. Recall from lesson 4.2 that increasing the exponent in a power of 10 by 1 is the same as multiplying the number by 10. Notice how the decimal point moves in the table below, and it is very hard to see, but we will continue to talk about how these decimal points move as we continue to multiply either by positive 10 to the power of that's a positive, or we're multiplying by a 10 to the power that's negative. So this is where I'm going to get into more of how to solve the actual step. The biggest thing was understanding what is the definition of a standard notation. Okay, so it says write each number in, scientific notation, standard notation. So standard notation is the typical way that we would write numbers. I cannot speak today. So your typical way you would write numbers. And so right now, these are both in scientific notation. So I'm going to show you what you need to do for each one to write them in standard notation. So first off, I'm going to look at A. A is written in standard notation because I have a number that's between 1 and 10. So this number is 3.12, and it's okay that it has decimals. And then I have it times a 10 to a power, and so this power is 9. Noticing that my power is a positive power is going to tell me how I'm going to rewrite this in standard notation. So in this case, it's going to make this number a lot larger. So I'm going to start by writing out this 3.12. And what I'm actually going to do is this 9 tells me how many spaces, so number of spaces, to move the decimal. It is a larger number, so guess what? I'm going to move it to the right. I want to make this number bigger. So I'm going to move it 9 spaces. And right now, it's easy to notice I can move it 2, but I can continue moving it and just add in some zeros. So I'm going to take this and I'm going to draw across. So this would move 1 space, 2 spaces, 3, 4, 5, 6, 7, 8, 9. Now every spot, the little divot here that I don't have a number, I'm going to fill in with 0. So really I'm going to have 7 more zeros, and so when I actually rewrite this out, I'd have 3, 1, 2, and then I said 7 zeros when I counted it out. 1, 2, 3, 4, 5, 6, 7. So if I add in my commas, it looks to be that I have 3,120,000,000 for this. It's standard notation. Looking at B then, I have a number between 1 and 10, so I have 1.35. Let's start by writing that out. This time, though, I have it times 10 to the power. That's a negative power. The negative power means it's going to be a small number, and so I'm actually going to move the decimal to the left. And I'm going to move it to the left 4. So it's a lot like a number line. Typically in a number line, if we're going positive, it's going to the right. If it's negative, we're going to the left. So we're going to move it 4 spaces, so 1. And again, now I'm going to run out where I need zeros. 2, 3, 4. And this is where my decimal would be. So one way I could write this is I could have, looks like 3 zeros and then the 135. So I could have 0.000135. Or if you like to add in that extra 0 in front of that decimal place, you can also do that. But it's not necessary. It's not necessary. These both mean the same thing, okay? So these would be some helpful things to write down, knowing that this is the number of spaces you move, that if it's positive, we're going to the left. If it's negative, we're going to the, or sorry, if it's positive, we're going to the right. If it's negative, we're going to the left. So another key idea here, then writing numbers in scientific notation. For numbers greater than or equal to 10, use a positive exponent. So again, if you're taking something that's in standard form and it's a really large number, you're going to put a positive exponent in with that for the standard form. If it's something that's smaller or less than 1, you're going to put in a negative exponent. Okay? The positive exponent makes a large number, negative makes a decimal, or a small number. So we're going to take this number and we are going to write this in scientific notation. So I'm going to start just by rewriting it. And so it looks like I have it looks like 6 zeros after that. 1, 2, 3, 4, 5, 6, and then a 3. So based on this, remember scientific notation is written as some number times 10 to the power of something. So I'm going to start off by writing it out with the 10 to a power of something. But I also notice that it's a small decimal, and so that means my power is going to be a negative power. From there, what I really want to do is I want to probably get this to be a 3, because I could put the decimal right here and have 0.3, but that's not in between 1 and 10. So my main number here would be 3. Now we just need to know how many spaces I'd have to move this decimal to get it back to being just a number of 3. So I'm going to count them. 1, 2, 3, 4, 5, 6, 7. I need it all the way to the right. And so that means that I would have a negative 7 as an exponent. And so writing this in scientific notation, I'd have 3 times 10 to the negative 7. So let's take a look at some word problems here. So it says a monarch butterfly has an average mass of 0.5 grams. In one roosting colony of Mexico. So I think where like a lot of them hang out, especially when it's cold here, they all go down to Mexico. It has estimated that there were 10 million monarch butterflies. Write the total mass in scientific notation. Whew. All right. So what we're going to do is, first off, I noticed that we had 10 million as well as we had this 0.5. So what I'm going to do is I want to figure out the total mass based on that. So we're going to multiply these two, and then we're going to take that number and change it to scientific notation. So I'm going to have 0.5 times then 10 million, and this is how I would write out 10 million. Now, multiplying anything by 0.5 is a lot like saying divided by 2. So if I took 10 million and divided it in half, and I'm sharing this 10 million, I don't know, 10 million butterflies, you and me get, half of these 10 million butterflies. What that's going to do is it's going to give me 5 million. So I need to write 5 million in scientific notation. So we're going to have something 10 to something here, and we'll have the number just 5. So we got to figure out how many decimal places. So if I just had 5, here's where the decimal place would be, because I could read it like this. And so how many how many spots is it from here to here? 1, 2, 3, 4, 5, 6 it looks like. It's a larger number, so I'm going to have a positive 6. And here is how I would write this solution in scientific notation. I think we just have a couple more parts left. All right, so the last part was talking about comparing your scientific notations. And to be honest, it sounds super tricky, but it's a lot easier than you think. So it says to compare two numbers written in scientific notation. First, compare the powers of 10. The number with the greater power of 10 is greater. If the power of 10 are the same, compare the values between 1 and 10. So for instance, say you're using this first one, they have 2.7 times 10 to the 13th, and they have 2.7 times 10 to the 9th. Now they both have this 2.7, but they're talking about the first thing you look at is that power of 10. So this is the power of 10 to the 13th, and this is 10 to the 9th. 10 to the 13th is going to make a lot larger of a number, and so in that case, 2.7 times 10 to the 13th is what is larger. If they end up having the same power of 10, as you can see in this one, then you compare that first value. So which one's bigger, 3.98 or 2.52? Well, 3.98 is larger. So we have one more problem. It's a pretty beefy, wordy problem. So let's see if we got enough time to read this. It says the major components of human blood are red blood cells, white blood cells, platelets, and plasma. A typical red blood cell has a diameter of approximately 7 times 10 to the negative 6 meter. A typical platelet has a diameter of approximately 2.33 times 10 to the negative 6 meter. Which one is greater diameter, the red blood cell or the platelet? So we're going to compare these two, so I'm going to write them out. And in this case, I'm already noticing that they have the same scientific notation, or that power of 10. So then I just compare these two values. 7 is greater than 2.33, so to show that, This one is larger, and so in this case, which one is larger? It's the red blood cell.